Up next, I'm excited to bring James Newton-King on. He's going to spend some time talking about high-performance services with gRPC with what's new in .NET 5. James, go ahead and jump in, my man.
Hi, my name's James Newton-King. I'm an engineer on the .NET team, and today I'm going to talk about gRPC and .NET. gRPC is a modern, high-performance way to communicate between applications. So our agenda for today, first I'm going to introduce gRPC to any developers who are new to it. I'll compare it to RESTful APIs, and I'll also demo building a basic gRPC server and client to call it. We're going to take a look at what's new in .NET 5. There are a lot of new features that have been added in the past year. And I'll also focus on gRPC performance in .NET. Performance is a big draw for gRPC, and there have been a lot of great improvements here. And finally, I'll discuss resources for anyone who's interested in learning more about gRPC. So what is gRPC? It's a popular open source remote procedure call framework. RPC frameworks make it easy for apps to talk to each other. There are alternative frameworks, RPC frameworks out there, Thrift, JSON RPC, WCF to name a few, but the developer community is really coalescing behind gRPC as its framework, RPC framework of choice. gRPC is run by the CNCF and the Cloud Native Computing Foundation. And what Microsoft has done is we have created a new implementation of gRPC built on high-performance .NET APIs, and we've contributed it to the CNCF. gRPC is not new. It was originally open-sourced in 2015, but it's built with modern technologies. It's a union of HTTP2, which is its transport protocol layer, and protobuf, which acts as gRPC's serialization technology for its messages, and also its language-neutral contract language. gRPC is designed for modern apps, particularly microservices. It's high performance. Both HTTP2 and protobuf are designed with performance in mind, and it's platform independent. There are gRPC implementations for every major programming language today. So you can be in .NET or Ruby or Go or C++, Java, Node, Python, you name it. You can talk between your apps using gRPC. They're all completely interoperable. So how does gRPC compare with RESTful HTTP APIs that I think most developers are pretty familiar with? So the first big difference is gRPC is an opinionated contract-first RPC framework. So that contract is defined in a protofile. That protofile is really the heart of gRPC. It defines your APIs and the messages that you're going to send. It's a language-neutral way of defining your APIs, and that's important because you pass that protofile to other languages and use it from them. And depending upon which language you're using, it drives code generation that will then generate you a strongly typed client and messages for your current platform. We compare that with HTTP APIs. They tend to focus on the shape and content of HTTP. So you're thinking a lot more about your URLs, your HTTP methods, your JSON, your headers, how to do serialization, and you tend to write code first, and perhaps as an optional step afterwards, you might use something like Swashbuckle to generate a Swagger contract. Compare that with gRPC, and that protofile really does come first. gRPC, the content is binary. HTTP2 and protobuf are binary protocols, and the content is designed for computers and high performance. Compare that with REST APIs. Actually, REST APIs are text-based, so HTTP 1.1 and JSON. They're human readable, which means they're great for debugging, but not so good for performance because the computer is having to produce text and then parse text. So it's really designed for humans to read and write, not computers. gRPC is designed to hide the complexity of remoting. gRPC libraries plus code generation mean you don't need to worry about routing and headers and serialization, a lot of those low-level concerns. When it comes to calling a gRPC service using a client, you've already got a strongly typed client, you're just invoking a method on it, you're passing your message, then you're awaiting the result. Compare that with HTTP APIs and REST. They tend to emphasize HTTP a lot more. You're thinking about those lower level concerns a lot more. which is good because you're given a lot of control over HTTP requests, but there is additional complexity because of that. So if I was going to sum up these two approaches, gRPC, it focuses on performance and developer productivity, while RESTful APIs, they're about the widest audience because every computer is able to talk HTTP 1.1 and JSON, and also the ease of getting started. You don't need to set up any code generation. And like if you want to call a RESTful API, you can just call it in a couple of lines of JavaScript. You don't need to get any other tooling involved. So with that, let's demo building a basic gRPC service and app for calling it. So first thing we'll do is we'll create our gRPC service. And the way that's done is we'll use our a gRPC template, which ships with the .NET SDK. So search for gRPC, and we can see we've got a gRPC service. We'll create this, and what will happen is we'll get a ASP.NET Core website set up with gRPC already, and also a basic gRPC service all ready to go. So give Visual Studio a second. Okay, so if we take a look at our solution folder, we've got a couple of interesting things here. First thing we'll look at is that proto file. So this is the language neutral way of defining your APIs. And here we can see we're defining a greeter service and a say hello method. So think of a service like a controller in MVC, and think of a method like an action. So our method is taking a hello request, which is a message that's defined down here, and it has a name property on it, and we're returning a reply, and it has a message. So this is basically hello world, where we've got a service, it's got a method on it, we're giving it a name, and it's going to return a message to us. If we look at the implementation, we can see we've got a service, greeter service, and we've got a say hello method. And in this say hello method, we're taking a request and we're returning a reply. And inside the actual method body, we're taking the name and we're concatenating it with hello, and we're returning it back to the client. Very simple and easy to implement. But one thing which jumps out to you is, where are these types coming from? Where is hello reply? Where is greeter base? These are all the types we have in our project. And the answer to that is they're coming from code generation. So code generation is generating these files based on our proto file definition. And if we F12 into our greeter base file, we can see we've got a whole bunch of generated code going on. So gRPC is doing all the heavy lifting of generating all this serialization code and routing code, and it's doing all of this so you don't have to. All you need to do is implement this greeter base class and override this method, and then write your implementation. And then likewise, it's doing exactly the same for all the messages. Like, you don't want to write this, you just want to focus on building your app. So now we have this, let's run our gRPC service. So we'll come along to the console and do .NET run, and Kestrel will start up, and we've got our web server now listening on this address. So let's browse to that in a browser, and we get this message: communication with gRPC endpoints must be made through a gRPC client. So gRPC isn't like REST, where you can like have a get endpoint and browse to it and you see some JSON results. gRPC, it really requires that proto file because it's a contract first RPC framework. Our client needs to know about that proto file, and right now our browser doesn't know anything about it. So what we need to do to call our gRPC service is we need to create a client. And the way we'll do that is we'll create a new console app project. And let's just change this to .NET 5. And now we need to add the proto file to it, because the proto file needs to be known both about the client, needs to be known both on the server and the client. Now we could copy it from this location, like we could copy the file to this location, also copy this code that is in our CS proj that's required for code generation to this other location. But But we've got a shortcut that Visual Studio provides. So what we can do in Visual Studio is we can add a connected service, and in here we can choose to add a service reference. And we've got a gRPC option, so we'll add a gRPC service reference. This will look quite familiar to anyone who's ever done something similar to this in WCF. We're going to navigate to our greet.proto file. So our file path is to our original project, gRPC service 49, and we'll select the type of code we want generated. We've got a bunch of options. Our server was generating server code. We want to generate client code. So we'll click Finish, and a bunch of stuff starts happening. So Visual Studio is just adding some NuGet packages that are required for our client to that project, and it also is adding a reference to that proto file. So if we take a look in our CS_proj file, we can see we've got our NuGet packages and this protobuf element. So this protobuf element is how code generation knows about the proto file. Here we're saying we want client code because we're in the client. And if we take a look in our server file, we can see we've got that exact same reference, but here it says server rather than client. Okay, so now that we have that, let's write some code to call our client, call our server. So first thing we're going to do is we're going to create a gRPC channel. So a gRPC channel represents the connection from the client to the server. And this address here, port 5001, that's the same port we saw up here from Kestrel. Then we're going to create our greeter client. So this is the strongly typed client that was created for us from code generation. Again, if we F12 into this, we can see we've got a whole bunch of code that has automatically been generated for us, including our a method to invoke our say hello method. You don't need to worry about this. This is all automatically generated for you. And then to call that, we just invoke it. So we're going to call say hello async, and let's make our method asynchronous to keep Visual Studio happy. All we're doing is we're passing in our hello request, we're passing in our name, and we're getting back our response after awaiting it. And then finally, let's write it out to the console. So if I get the path to this guy, I'll just compile it. Let's run our gRPC client. And if everything has gone to plan, it's worked. So what's happened is we've sent .NET Conf off to the server, and then the server has handled it, concatenated our new message, and it returned it back to the client. And we can see over here on the server, our HTTP2 request has come in of application gRPC. Our gRPC endpoint has handled our request, and it has then returned it back to the client, and we can see that it has finished processing it. That's a very basic gRPC call. That's called a unary call. So gRPC, as well as supporting a standard request and response, gRPC also supports streaming. So a streaming call is when you send, instead of just one request, you can send multiple requests or responses. So in this case, we're going to create a say hello stream method. We'll update our proto file. And now, instead of returning a single reply, we're returning a stream of replies. To implement that on the server, we're going to override the new method, which has been code generated for us. And notice that the method signature is slightly different. Instead of returning a single reply here, now we have a response stream. So what we're going to do is we're going to write to our response stream. We'll write 10 messages. And to each time we'll call write async on our response stream, and we'll create 10 replies. And our message will be very similar to what we had earlier. Hello request name. And we'll be slightly different here. We'll include a number so we can tell them apart. And because streaming happens very, very quickly by default, let's add in a delay. Actually, we need to make this method async. Let's add in a delay. So we'll add in a task.delay of 1 second. Let's compile this. So if everything has gone to plan, start up our server again, and we'll run our client, and we should start getting back a stream of messages. Oops. So we've updated our server. We need to update our client. So to update our client, what we'll do is instead of calling say hello async, we'll call say hello stream. And again, we'll pass in our request message. Say .NET-conf streaming. And instead of awaiting our call, now on the client, we also have a response stream. So what we can do with this response stream is we can do an await for each. So this is just like a regular for each, but it doesn't block the thread. And we'll write out our result from the server. Okay, now I think we should be better. Okay, so our streaming call has started. You'll notice there's this delay between all the messages. And as we reach number 10, you can see our call has started. And our call should now finish. And it's now finished. And we can see our call has taken about 10,000 milliseconds or 10 seconds. So that's gRPC basic unary call and server streaming. A powerful feature, but also very easy to use. So what have we done in .NET 5 for gRPC? There are a bunch of new features. gRPC is now supported in the browser with gRPC-Web along with .NET. So what gRPC-Web is it modifies gRPC slightly, so it makes it compatible with browsers. Because browser APIs like JavaScript APIs like Fetch and XHR, they don't support standard gRPC by default. So gRPC-Web is a slight modification. And in .NET, we now have server middleware that is able to handle gRPC-Web calls. And we've also created a Blazor client. So if you're within a Blazor WebAssembly app, you're able to invoke gRPC-Web from within your Blazor application. .NET 5 and gRPC now is hosted, support's been hosted by Http.sys and IIS on Windows. Note that Windows changes were required to support this feature, and because of that, you'll need a modern supported version of Windows that has these changes in them. Current insider builds of Windows have support for gRPC and Http.sys and IIS. gRPC is a great choice for communicating between processes. gRPC client and server can now use efficient IPC transports like Unix domain sockets and named pipes. So you could do IPC communication between processes before, but before it always had to be TCP. Now you can use UDS and named pipes. And finally, .NET 5 introduces trimming to reduce app size, kind of as like a preview feature. You can use that today pretty well with gRPC at its highest level. Because gRPC uses a lot of code generation for its serialization, gRPC already has excellent support for even the most aggressive trimming levels in .NET 5. So I've got a bunch of slides here talking about why gRPC is really fast, what HTTP2 features it uses to get such good performance, and also how it's able to use protobuf to create really small messages. But I think rather than talking about it, I'll show you. So I've got a gRPC WebAssembly app, and it is set up to fetch weather data from the server. And there are two options. We can either fetch JSON, or we can fetch gRPC web data. So if we fetch JSON, we'll make a call off to the server. We can see we've got a whole bunch of results that have been returned to us, and we can see our data size. It's about 100 kilobytes in size for the data, and it took like half a second to deserialize it. If we then go back and we change this to use gRPC-Web instead, we can see now we're just a fraction of the size. We've gone from 100 kilobytes to a quarter of that size, like about 25 kilobytes. This is the exact same data or equivalent data, weather data, just represented in protobuf and gRPC instead of JSON and REST. And we can see the deserialization time, it's now just like less than 20% the previous time of half a second. If we take a look at our requests inside the network tab, we can see we've got our first call, which is our JSON call, and we can see the great big JSON web request being returned with all this information. If we then compare that to gRPC call, this is the binary representation. This is the protobuf messages that JSON has returned, that gRPC has returned, and as you can see, they're much smaller. And we can compare that directly over here in the network browser. So we've got 100 kilobytes for our JSON call and just a fraction of that size for gRPC. So what work has gone into gRPC performance in .NET 5 to make it even faster? So the biggest improvements have come from optimizing HTTP2 and HTTP client and Kestrel. We've reduced latency, we've improved concurrency, and we've removed a lot of allocations. In fact, server allocations have reduced by 92% compared to .NET Core 3.1 and compared to .NET 5. And these improvements are great because it isn't just gRPC that benefits from the HTTP2 performance improvements. Every app that's using HTTP2, whether it's using REST or it's just a normal website, they also are able to share in these improvements. Kestrel now supports HPAC dynamic compression of response headers. So HPAC compression is able to take commonly occurring headers like content type, and instead of just sending the same data down with every response, it's able to compress it down to just a couple of bits. So huge potential savings, although headers tend to be quite small. We've worked with the protobuf team to add support of span of T and other advanced .NET Core memory features to the protobuf serializer. And with those features, when we do protobuf serialization of messages, we no longer need to allocate a temporary buffer when serializing and deserializing. We can do that directly to a web server's memory. So what's the end result of these performance improvements? Our server requests per second have increased by 65%, and client requests per second have increased by 220%. So these are the improvements that you see in .NET 5 compared to .NET Core 3.1. And how does gRPC on .NET compare against other gRPC implementations? So this is a community benchmark of different gRPC implementations and comparing their server performance. You can see .NET and gRPC, we were second in the results. So we're at the very top with other fast implementations like C++, Go, and Rust, and you can add .NET to those other fast implementations. So if you're interested in learning more about gRPC, let's talk about some of the resources that are available. We've spent a lot of time investing in documentation. This is just a brief summary of what's available. But if you have any questions about using gRPC or you want to learn more, I recommend going to docs.microsoft.com. There's also a quick link here. And we've also written a lot of basic examples. Each example shows one or two core concepts in action, whether it's streaming or showing you how to do authentication or unit testing with gRPC services or clients. They're all available on our gRPC repo. GitHub repo. And that's all I have time for you today. I hope everyone has learned something about gRPC and using it on .NET, and hopefully now we have some time for questions.
We do. Thanks, James. There was that's lots of great stuff. That was a good deep dive. And there's been a bunch of really good questions in our that people have tweeted out with the hashtag .NETConf. So we'll get into a couple of those. The first one from Kier asks, James, is there a way to have your C# code as a single source of truth and generate those .proto files from code, maybe using source generators?
So source generators, I don't believe you can take a proto file and then generate C# from it. I don't know if source generators support that. If you want to have a code first approach to gRPC, so not have that proto file, there is a community implementation that builds on top of our gRPC library that supports code first. I believe it's called protobuf.net-gRPC, and it enables code first. So you define your contract using a C# file rather than a proto file. It's great if you're just talking between C# applications, but the great thing about a proto file is it's language neutral, so you can give it to any platform, any language, and they're able to use it.
Awesome. Okay. We got a couple more minutes, so we'll do a couple more questions. This one from Bitbonk. James, is it possible to serialize and deserialize classes that are not known at compile time with gRP somehow? For example, if we have polymorphism.
So there is a documentation, a doc in docs.microsoft.com that talks about working with more dynamic protobuf messages in .NET. So there are a couple of options. There is a type known as any in protobuf. So like you can have a message type of hello request. There is a special gRPC protobuf type called any, and with it you can specify like a message, and then you specify its name, and then the client is able to read that name of that message type and then deserialize it. But I recommend looking at docs.microsoft.com, and there is a doc on there about protobuf messages, and it has lots of information about doing that sort of thing.
All right, cool. We got one more. This one's from Dennis. Is there an analog of Swagger for gRPC?
It's that proto file.
Okay.
So that proto file is the contract.
The
yeah.
Perfect. Okay. James, thanks very much. We covered a lot of the good questions, and we're right on time.